so sorry, but that first video actually went up until giving you the equation of the perpendicular line, but I didn't actually find distance, and I just realized that after I had concluded that video. So I made that video part one, and that's giving you all the instructions you need to get the perpendicular line, which is indeed the perpendicular bisector of line M. Now I'm going to show you how to actually calculate the distance. So what you have is you have line M, you have point C, and now you have this perpendicular bisector. So what you need to find out is where that intersects. So for the purposes of this video, my intersection point here is not great, but we're going to, for the basis of this example, we're going to assume that it intersects at 1, 0. Okay, so I'm going to say that the line intersects at 1, 0. And for the purposes of this problem, so C was at -3, 5. I'm saying the intersection for the purposes of this example is at 1, 0. Okay, so you can see how you calculate distance. Okay, so you have point C, which has coordinates. You have your intersection point with line M and your perpendicular bisector. You can find the distance using distance formula. Now, remember, distance formula was way back in Unit 1, okay? And that was D is the square root of the difference of x2 and x1 squared and y2 and y1 squared, okay? So the difference between the distances of your x added to the difference of your distances of your y's, both of them squared, and then you take the square root. Okay, so for the purposes of our example, C here was -3, 5, and I'll label this point D. This is point D. So D is 1, 0. So I'm going to subtract the differences of my x's, square it, add it to the differences of my y's, square it, take the square root, and that is my distance. So here I'm going to have 1 minus a -3 is 4. So D is the square root of 4 squared. And then 0 minus 5 is -5 squared. 4 squared is 16. 5 squared is 25. So we have the square root of 16 plus 25, which is the square root of 41. So the distance from C to line M is a distance of square root of 41. Okay, so the first video, again, just to quickly reiterate, the first video goes over how to get the equation of the line for the perpendicular bisector. So that's what I gave you in the first video, in the first part. This second part actually calculates the distance, okay? So, and again, I will reiterate, the purposes of this example, my line was not great. So where I thought it intersected, I just decided to make it 1, 0 for the purposes of this example. You use distance formula to find the distance from point C to D, which is going to be on line M. That will give you the distance. So if I could find a way to get a better color here. Okay, so this distance here, so here is C. Hopefully you can, you might not be able to see it. Maybe if you zoom in, okay, but C to D. So right here, that distance that is bolded, that distance is the square root of 41. That is D. Okay, so that little bold line segment right there, that is the distance from C to line M. That has a length of the square root of 41. Okay, so this video is how you calculate the distance. The first video is how to get up to the point of finding distance. Again, any questions, feel free to post comments. Please do that. Thank you.